Okay, this is a short video on graphing logs. I'm going to show you the couple ways. One will be the essential way. The other one will be like a little shortcut that you can kind of just graph right on the spot. But what you want to do is basically understand that logs and exponents are inverses of each other. Inverses means that when you have a coordinate x and y, to find the inverse of that, you just simply flip the numbers from x to y to x, and these become the new inverse coordinates. Okay, so when you have to graph a log, yes, there's a really easy way to do this, which I'll do it in a sec. But the right way to do this is to convert this into its exponential format. So what you do is you first figure out what base the log has, and turn that into an exponential form. Y equals log of x. And then what we're going to do is list about 3 or 4 coordinates, very easy ones like 0, 1, 2, 3, and just plug it in. If you plug it in, you get 10 to the 0, which is equal to 1. 10 to the first power is just 10. 10 to the second power is 100. Oh, great. 10 to the third power is like 1,000. That's kind of big, so I'm not gonna do that last one. Okay, and then what you do from here is you have to flip it. Okay, so these will become, and I'm gonna put this in the blue color, the new xy for your log graph. So these are your exponential functions. We have to find its inverse by flipping it. So this is gonna become 1, 0. Or actually, you know what? Let me go back and let me just redo this part right here. So because the numbers are so big, so instead of 1, 2, and 3, let's put negative 1, 0, 1, and 2. Okay, so if you put negative 1, it's 1/10, 1, and then 10, and then 100. Okay, all right, and then we're going to flip these two into its inverse coordinates. Okay, so it'll be 1/10, negative 1. And then 1 comma 0, 10 comma 1, and 100 comma 2. Okay, so this is your log coordinates. But now what you have to do is you have to apply the transformation. Now, anytime you have a parenthesis with x being positive, whatever number you have there, you go opposite direction on that x-axis. So you can show that, and I'll do this in green, by writing like this: x minus 6 and y plus 2. This is your vertical shift. You just leave it the way it is. If it's plus 2, you add 2. So what that means is you're going to take all of these coordinates of like an original log function, and you're going to shift everything left 6 spaces. Okay, so we have to subtract 6 to all the x coordinates. So 1/10 minus 6, what is that? 5 and 9/10, negative 5 and 9/10. Negative 1 plus, well, I'll do all the x's first. So 1 minus 6 is negative 5. 10 minus 6 is 4. 100 minus 6 is 96. And then we're going to add 2 to all the y coordinates. Negative 1 plus 2 is 1. 0 plus 2 is 2. 1 plus 2 is 3. And 4. Okay, so these are your coordinates for this guy. Okay, and we got that from this. Taking the inverse original parent function and flipping it to this, and then taking all of these and applying the transformation to these coordinates. Okay, so now we just have to plot it. Now, what you want to do is you always want to plot the asymptote first. Now, all log graphs basically have a vertical asymptote at x equals 0. You see that? So that's the first thing you want to move. If you're going to shift left 6 spaces, you have to shift that dotted line left 6 spaces. So 1, 2, 3, 4, 5, 6. And here is your asymptote. You always want to draw that first, okay? And then we're just going to plot the green coordinates here. I'll do that in green. Negative 5 and 9/10, which is right here, and 1. Negative 5 and 2. Negative 4, 1, 2, 3, 4, and 1, 2, 3. And then you got, wait, oh, that's positive 4, sorry. Negative 5 and 2. Okay, let me try again. Negative 5 and 9/10, 1. Negative 5, which is right here, and 2, 1, 2. And then you got 1, 2, 3, 4, 1, 2, 3. So it's going to go like this. And then you got 96, we'll just, play it by the ear. Okay, it went up just a unit. So it's a very slow growth. Okay, so I'm gonna mark these coordinates. So 96 comma 4, 4 comma 3, negative 5 comma 2, and negative 5 and 9/10 comma 1. Now, if you want to if your teacher says you have to also graph the log's inverse, all you have to do is take the what do you call it, the vertical asymptote and turn it into a horizontal asymptote. If it's negative 6, then it'll become y equals negative 6, which will be right here. I'll do this in blue. No, not blue. I'm gonna have to do yellow. Okay, so 1, 2, 3, 4, 5, 6. So it will look like that. And then take all the coordinates that you have here and just reverse it. So instead of, let's see, we'll start with this one. Instead of 1, negative 5 9/10 comma 1, you flip it around, it'll become 1, comma negative 5 and 9/10, which is somewhere right here. And then instead of negative 5, 2, it'll be 2, negative 5. 2, negative 5 will be right there. And then 4, 3, 4. So it'll be 3, 1, 2, 3, 4, which is like up here. Okay, so it's gonna go like, and then 96, 4. Okay, well, 496. You go 4 all the way to 96 will be really, really high. So if you see what's going on, it'll be like so. Oops. Okay, now if you do it right, it's always going to reflect off the y equals x asymptote, which is right here. Now I'm gonna have to kind of, okay, all inverse graphs reflect off of each other. Okay, so this green one is your y equals log 6, I'm sorry, log base 10, x plus 6 plus 2. The yellow one is your exponential, the inverse graph, which is your exponential graph. Okay, and by the way, this one right here, you can make it like this. This is your inverse of log. Okay, and that's basically it. Now, I told you there was an easy way to this, right? Yes. So what I do is all you have to do is, again, take your original asymptote, which is there, and your original coordinate 1, comma 0. All log graphs look like this, essentially. And then what you do is you basically take this graph, shift it left 6 spaces and up 2. You can start with always start with the asymptote. So you go left 6, 1, 2, 3, 4, 5, 6. Draw your asymptote there. The x-intercept, you move it back 6 spaces. So it's going to land right there. And then you're going to move it up 2 spaces. 1, 2. So let me erase this one because we don't need that one. And then you just graph it in the same shape. There it is. And this is your graph. It's that easy. But the only problem is when you have something like, what do you do when there's a negative, right there? Then you have to like flip it upside down. So if you're really good at graphing, yes, you can do it this way. If you need coordinates, I would say learn to do this quickly. And your teacher will see that you've done a wonderful job here. You have all the coordinates to prove that you know what you are actually doing. Okay. All right, so here, let me do it one more time. Okay, one more time. So again, we're going to switch this to an inverse graph, an exponential form, but the base here is 1/4. So this is going to become 1/4 to the what? X power. You see it? We're going to list the coordinates for this one. So if I want to plug in easy numbers. Now, it's to the 1/4, so I'm going to give it like a couple negatives because I'm going to flip it around. So -2, -1, 0, and 1. If I plug in 1, you get 1/4. If I plug in 0, you get 1. If I plug in -1, you get +4. If I plug in -2, you get 4 to the second power, which is 16. Okay? And then what do? You take that. Well, should I just keep it color-coded? Okay, so I'll do the blue. Okay? So blue. So this is now my original, well, your parent log graph. So we're going to flip it. So 16 comma 2, 16 comma -2, 4 comma -1, 1, 0, 1/4, 1. And then you apply in the green the transformation. So it's going to shift right 1 space. So this would be x plus 1 and then y plus 3. Okay, so we're going to add 1 to all the x values. So this would be 17, 5, 2, and 1 and 1/4. Add 3 to this one. You get -2 plus 3 is 1. 2, 3, and 4. Now, before you graph or before you plot points, you always graph what? the vertical asymptote. It's going to shift right one space. So we're going to put it right over here. Okay, and then you just plot those coordinates. 17, 1. Okay, somewhere here, like that. 5, 1, 2, 3, 4, 5, comma 2. Again, it's not drawn to scale. All right, fine. I'll just move it all the way over. We'll do that afterwards. And then 2, 3, 1, 2, 1, 2, 3, and then 1 and 1 4, 4. So you see that it's going like this, right? Oh wait, it doesn't technically. Okay, it can go like this. Yeah, there it goes. Okay. And then again, all right, I'll just do step by step. This is 1 and 1/4, comma 4, 2, comma 3, 5, comma 2, and oh, you know what? 70, comma 1, right? 17, 1. Okay. So 17, comma 1. All right. There we go. But it keeps on going down. It's going to cross the y-axis eventually. Okay, now from this point on, I think you should know how to do the rest. Like domain is from 1 to infinity. The range is negative infinity to positive infinity. And the limit as x approaches positive infinity will be negative infinity because it's going to go down. The limit as you approach 1 this way, it's going to become positive infinity. Okay. All right. Well, I hope that helps. Let me know if you need any help.